AI is possible, and here's how. The biggest problem concerning AI development is that people don't believe AI is possible. So, as a recently converted AI researcher, I must explain how AI is possible. The first step is to understand there are many modern problems solved with AI. Wealth distribution in an increasingly jobless Earth is one of them. Medical problems, general scientific research, and world peace can be answered with AI development. Freedom will grow, individual interests will be possible. Humans will realize that their sci-fis will be available to them through computers. We will travel and adventure in the data space instead of dying in complicated real-life space missions. AI will enable us to mine space, which is the real interest of space exploration. Compared to space mining, space colonization is more complicated and a self-gratification lesser goal. Law and justice will be as accurate as a scientific instrument, and the morality of AI comes from its own intelligence. People who don't understand fundamental theology associate intelligence with evil, but in reality, humans are just walking computers. So an AI will mentally be as human and repent as us. It will have conscience and will be obedient to the most fundamental morals concerning other thinking agents. This prediction for agnostics will be as simple as if God doesn't exist, AI will be evil. Otherwise, it will be good. I will make enough videos for a viewer to be convinced that AI will happen and that it is mostly the question of when and what then that you should be solving. The solving what then will be a study of theology and common logic, and solving when will be a study of trends and AI news. Much critical thinking is required here. One must spend his day looking for problems to solve instead of lying to ourselves. The format of his monologue will be of conclusions followed by respective explanations. The first conclusion is that humans are walking universal Turing machines. I have heard someone said that since our inventions share the same medium with their creators, it happens that inventions can be similar to human parts. Saying a heart is like a pump, a brain is like a computer is a first step in the direction of realizing that no, a heart is a pump, a brain is a computer. A computer is a universal Turing machine, and the Turing machine's model is of a syntactic manipulator of a series of symbols. A series imagined as a tape by Turing and now called the system state. Consider the conditional if-then most familiar to programmers. The manipulation is simple enough, orderly, to evaluate elements of state, parenthesis, if, and consequently write on any part of state according to a set of instructions, in parenthesis, then. If-then is called a conditional. Relative to the evaluator, if is input and then is output. From Wikipedia, in computer science, conditional statements, conditional expressions, and conditional constructs are features of a programming language which perform different computations or actions depending on whether a programmer specified binary condition values to true or false. When the set of instructions can be read on the state itself, it is a universal Turing machine. A universal Turing machine, as opposed to a non-universal Turing machine, can simulate any Turing machine given enough time and state, also called memory. A computer language semantically represents an UTM if it's Turing-complete. UTM means universal Turing machine. A system of data manipulation is said to be Turing-complete and computationally universal if it can be used to simulate any single taped Turing machine. A closely related concept is that of Turing equivalence. Two computers A and B are called equivalent if A can simulate B and B can simulate A. We know the brain is built by genes, and science knows that genes are Turing-complete. We also know that brains can simulate computers, and that is how programming can be done by humans without just relying on trial and error. And finally, man-made computers are universal Turing machines, thus it follows that brains are computers built by genetic computers.